Hey, fourth graders, welcome back. I hope you had a great weekend. Today is Marvelous Monday, and it is October the 12th. Are you ready to jump right into Number Corner? Awesome, I am. We have a couple things on our list to do today. We are going to look at our calendar grid collector, and we are going to actually have some time to talk about it today. I know you may have noticed some things on our observation chart last time, but today we're going to talk about it. We're also going to update our Race to the Millions, and it's my turn today. Hopefully you remember some of the strategies we talked about that you may want to use when playing this game. Lastly, we're going to talk about multiples of 8. So buckle your seatbelts. Make sure you're making the effort to participate with me because you're responsible for learning this information. So here we go. Today I said is October the 12th. But let's see what happened on the weekend. Zoom in. You can really see it. Looks like we have a quarter, a dime, and a nickel. Okay. Well, let's see what Sunday looks like. Yeah, we have 4 columns shaded in. You got it. Well, let's also look at today, and then we'll start filling in our calendar observation chart. Yeah, cool. So are we ready to talk about it? Awesome. Here we go. So before we jump right into today, which is October the 12th, I want to show you how I got a 4th for October 8th and also a 4th for October 9th. So I'm going to jump to my Money Pieces app really quickly. And you know, we've talked this whole time about relating things to a dollar. So since October the 8th had a quarter, I'm going to pull my quarter on my Money Pieces, which is worth 25 cents, and put it on top of my dollar bill, which is 100 cents. We have 100 of these tiny squares here. So you can clearly see that we would need 4 of these, or you could think we need 4 quarters to make up a dollar. So if I have something worth 25 squares shaded in, or a quarter, then we know that that's 1/4. And so that's why we have 1/4 here and we have 1/4 here. So now let's talk about day 10, which was a quarter, a dime, and a nickel. Well, how much money is that worth? Yeah, it's 40 cents. I'm going to write it like this. All right. All right, so it's 40 cents. We don't have to relate it to money because it is money. So then how would I write that in a fraction? Right, it will be 40 hundredths. Or let's look at our Money Pieces again. So I have 10, 1 10, 2 10s, basically with 4 shaded in, right? 3, now 4. So 40 cents out of 100 cents, right? But how many tenths do we have? You got it, 4 tenths. I'm going to also write that because remember, we're also talking about equivalent names for our numbers. All right, so then how do I write that as a decimal? Good, or, right, because that means 4 tenths. This is 40 hundredths. Right, so let's jump down to our marker for the 11th. Yeah, I actually just showed you that on the Money Pieces. So it's like money because it's worth 40 cents. 40 squares are shaded in like 40 cents. And so we have the same fraction, you're right, and the same decimals. Very good. Now, what about today's marker, which was the 12th? How is that related to money? I'm going to pull up my display copy here just to refresh our memory. And we know that each of these are worth a unit, but how is that related? How is that related to money? And we have this pentagon here. What could we do to make this look like tenths, possibly? Good. We could draw lines like this, like this, like this. And we can make this into tenths. And we like tenths because remember we talked about tenths being a dime, right? So then even if we didn't have those lines there, how many cents would go in each of these fifths? If you took $1 and you split it between 5 people, how much money would each person get? Hopefully this is a clue because we know a tenth is 10 cents. Right, it would be 20 cents that each person would get if this was $1. So then if we're looking at our calendar grid marker, since we have 2 shaded in, what is that worth? Yeah, it's like 40 cents, just like the other ones. It's like because each section is like having 20 cents. You can just write it like that. Okay, so how do I write that as a fraction? Good, same deal. 40 over 100, which is 4/10. But let's write it as a fraction based on what we're actually seeing here. How many of these sections are shaded and how many sections do we have in all? Right, so this is actually 2/5. 40 hundredths. It's the same thing as saying 2/5. Let me show you that on here again. So we could change some of our, or add some equivalent fractions to our marker for the 11th and for the 10th. Let's look at this, since we have 10 units, or 10 of these squares within the rectangle. And I could separate it into 5 groups. And if I did that, it would look like this. Here's a group, here's a group, here's a group, and here's a group. Now I have 5 groups. And so potentially, if I have 2 of these shaded in, that's saying I have 1/5. So I'm going to add 1/5 to our or is it 1/5? No, Ms. Trammell made a mistake, right? Because there are 4 columns colored in here, which is 40 cents. And then this is worth 40 cents, which means I would have 4 of these shaded in. So that's not 1/5. It is, you got it, 2/5. But if I only had 2 of them shaded in, like earlier, then I could say it's 1/5, like what we saw on the 7th. That's 1/5, and we have that there. Perfect. All right, so that's all for our calendar grid today. Now we're going to move into our, let's do Race to the Millions next and save our multiples for last. So here we go. It is Miss Trammell's turn, and she's going to spin. Remember, we talked about strategy. We want to keep the smaller numbers for the smaller place values and the bigger numbers for the bigger place values. So I'm crossing my fingers. I hope to get a really good number so I can beat you guys. Let's zoom in to make sure, because I feel like, yeah, it's definitely a 1. Okay. So that means I'm going to probably put my 1 in, you guessed it, I'm going to put my 1 in the tens place, much like you guys did when you rolled a 1. And so that leaves me with 10. Yep. And if I add my 10 to my 36,200, I'm going to get 36,210. So who's winning right now? Which number is bigger? Yeah, 44,000 is bigger. So if I were to read this as an inequality, it would sound like this. 36,210 is less than 44,010. Right? We're good? All right, this game can turn around quickly, so I guess we'll see what happens. All right, now we're going to talk about multiples. Let's look at our number line. You may remember this number line from last time. Oops. Okay, so take a moment and look at our number line. Remember we talked about multiples of 2, multiples of 3, 6, and multiples of 4. Right. So then a multiple is good job. So we're going to add our multiples of 8. So what is a multiple of 8? Give me an example. 8. Yeah, 8 is a multiple of 8. Do you think some of the multiples of 8 have already been marked? Which ones? Well, why? All right, so then about how many multiples of 8 are there between 0 and 100? Yeah, less than the amount of multiples of 4? I think you're right. So we're going to figure it out. We're going to count by 8s using the same count around procedure that we've done. And so every time we get to a multiple of 8, we're going to say it out loud. And if we're not on a multiple of 8, then we're going to whisper it just like this. Okay? So I want you to make sure you're saying every number as we go around or go through our number line here. Watch and listen. Make sure you're watching and you're listening. And be ready to tell me or to help me recognize multiples of 8. Are there any questions? We're going to do multiples of 8 and let's see. We're going to put a dot above the number. I want to do brown, but we don't have brown, so I'm going to do orange. Okay? Any questions about how we're going to start counting? All right, so here we go. 8. Oop, gotta select it. So 8. Good. 16 is a multiple. Good. 24. All right. 32. Are you noticing a pattern yet? Not yet? Okay, let's keep going. 40. How about now? How many multiples have we recognized? What times 8 is 40? Yeah, 5. So we've recognized 5 multiples so far. 1, 2, 3, 4, and the number 8, which was our 5th one. So maybe now we'll start to see a pattern because maybe the pattern's going to start over since we have a 0 in the ones place. We'll see. 41, 32. Right, 48. What number do you think is going to be our next multiple of 8? Let's see. We had an 8 in the ones place, and then we had a 6 in the ones place, and then a 4 in the ones place, and then a 2, 0. Now we have 8. Oh, you think it's going to be 56? Because it has a 6 in the ones place? Let's see. 48, 49. 56, yeah. 57, 58, 60. That was 4. Doing multiples of 8, okay? 64. Is that a multiple? We lose count. 1, 2, 3, 4, 5, 6. Nope, not a multiple. 71. 72 is a multiple. Yes. Anybody know what 8 times what equals 72? 8 times 9. You got it. So let's keep going. 80. 84. 88. It looks like our pattern is repeating. We have an 8, and then we have a 6, and then we have a 4, and then we have a 2, and we have a 0, and then it starts back over again. So since we have an 8, what's going to come next? We had 0, 8. What's going to be in our ones place? Yeah, probably a 6, right? Because this would be 1, 2, 3, 4, 5, 6, 7, 8. Right, so 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, and we're done selecting or identifying our multiples of 8. Did you notice that we selected or identified less multiples than we did with 4, than we did with 3, than we did with even 6? I wonder why that is. Do you know? Yeah, we're counting by bigger numbers and bigger groups. We're going to have less of them, especially if we're only talking about being within 0 to 100. So, can we see any relationships between multiples now? We saw some earlier with 2s and 3s, or 2s and 4s, and 3s and 6. What relationships do you see now with adding 8s? Great. Multiples of 2 and multiples of 4 are also multiples of 8. You're right. Well, what about this red box? Those are multiples of 6, right? So are you saying that some multiples of 8 are also multiples of 6? Yeah. So it looks like multiples of 8 are also multiples of 2, which are also multiples of 4, for all of them 2s and 4s, but also for some 6s and some 3s too. That's interesting. Right. Do you see that it doubled? Right. So we went from having, how many multiples of 8 do we have between 0 and 100? Let's count them. 1, 2, 3, 4 was 32, and 5. So for every group of 40, that's 5. So 40 and 40 is 80. So that's 5 plus 5 is 10 multiples of 8 so far. For 80, it's 10, 11, 12. 12 multiples of 8 between 0 and 100. So if we were to talk about multiples of 4, we'd have to double that, right? And then if we talk about multiples of 2, we would have to double that again. You got it. So for every multiple of 8, there are going to be some multiples of 2 in between and a multiple of 4 in between. One multiple of 4 in between, and 3 multiples of 2 in between. Yeah, so we got our multiples of 8. I want you guys to continue to think about what's happening as well as why it's happening, because multiplication is a big deal in 4th grade, and I really want you guys to think about and really see and understand the relationships between these multiples. Okay, great job in Number Corner today. I'll see you guys tomorrow. Bye.